Right, today we're going to look at the surface area of a prism. Now, we all know what a prism is. It's a shape that has a uniform cross-section, like this triangular prism, for example. Has two sides exactly the same, opposite each other. So it's a prism. A cylinder could be a prism. This kind of looks like a cylinder. It's not exactly a cylinder. Okay, we've looked at the volume of a prism. Now we're going to have a look at the surface area of a prism. What do we mean by surface area? We mean it's the area, it's the total area of all the different sides or all of the outside of the prism. And I have to add them all together. So in effect, how much paper would I need if I wanted to actually cover this prism here? How much paper would I need? I need to cover this, so I need a certain area, a triangular area, and all these around rectangles. All these areas all together make the total surface area of this prism. If we're looking at a cube, okay, all the sides are the same. They're all square. Like this Rubik cube, okay. Now the area, let's say we're trying to find the area of one side. And let's say the area, the side length is A. Okay. If the side length is A, then the area of one side, which is a square, would be A times A, which is A squared. So the area of one side is A squared. Altogether we have 6 sides. Front, back, the 2 sides, the top and the bottom. So altogether we have 6 sides. So the total surface area will be the area of all the 6 sides. So it will be 6 times, basically 6 times A squared, or just 6A squared basically. 6A squared is the total surface area of a cube. And we can find that just using our logic really. Right, let's have a look at an example. All right, all we have to do really, if we know the side of the cube, say this is, say, for example, 4 centimeters, then we would just plug in the 4 here. So 6 times 4 squared, or 6 times 16, which will be 96 centimeters squared. Okay, so let's look at this example. In this example, they're telling us that the total surface area of a cube is 150 centimeters squared. So in this case, they've given us the surface area. And they're asking us to find the length of the side. So we know the full area of the outside. The total surface area, they've said, is 150. And they want us to find one side. I know the total surface area, the formula for that is 6 sides of A squared, and that's 150. I just rearrange this, which is 150 divided by 6. So A equals 25. A squared equals 25, so A equals the square root of 25. So find the length of each side. The length of each side must be 5 centimeters. Is my answer. That's the first example. That was not too bad, was it? Right, let's now look at a cuboid. A cuboid usually means not all the sides are exactly the same. You usually have, it's like maybe a tissue box, for example. That's a cuboid. So we have a length, or this could be the width, the length, the height. Doesn't matter what you name them. Okay, ABC, ABC, doesn't matter. Okay, it could look like this. This could be your A, your B, your C. It has 3 dimensions. We all know that from when we did the volume. We said the volume of a cuboid is A times B times C. Now we're looking for the surface area. Okay, it could be standing up. It could be a cuboid that's more upright. Okay, it doesn't really matter. The point is it has 3 dimensions. We all know what a cuboid is, I believe. What's the area of the front? The area of the front will be A times C. So we have 2 of those. So it's going to be, we have 2 of those because we have one at the front and one at the back. If we think about it, we have one at the back right here. So there's another one opposite here, exactly opposite. Okay, so the area of the front and back is 2 times A times C. Okay, so 2AC. The area of the side, so let's say this side here, and opposite there will be another side over here. Okay, the area of this will be B times C. So the area of the sides, I have 2 of those. I have one on each side, so it's 2 times BC. So it will be 2BC. The area of the top and the bottom. The area of the top and the bottom, well, we can see is A times B at the bottom, which will be the same on the top. There are 2 of those, so it will be 2AB, will be the area of the top and bottom. Now, bearing in mind, if they tell you it's an open top one, so there is no top, because sometimes there will be no top, depending on the question. Just read the question carefully. Then this would be just AB. There wouldn't be 2 of them. Okay, but for now we're assuming it's closed because they haven't told us it's open. So this is a general formula we're trying to find. The total surface area will be the addition of all of these 6 sides. So 2 of those, 2 of those, 2 of those. So we add them all together. So 2AC plus 2BC plus 2AB. It's basically all the different combinations of the letter that exist times 2. If we factorize that, the 2 is common. It's AC plus BC plus AB. So either of these 2 are the general formula for the total surface area of the cuboid. Right? We can also look at this as being one side AC, which is, where is AC? AC is this front. I take one of those. I take one BC, which is the side, and I take one AB, which is the bottom, and then I'm just doubling it afterwards. I add all those 3 sides together, and then I double because there's also the opposite side to consider. So it's the same thing, really. Okay, let's look at an example here. We have a simple example. Find the total surface area of this cuboid. So we have the 3 dimensions. We have 11, 6, and 4. So the total surface area is 2 times, I'm going to just put them like this because I prefer, the different combinations. So 2 times, I will say 4 times 6. It doesn't really matter which order we do it in. Plus 4 times 11 plus 6 times 11. All right, it doesn't matter which order you do it in. So it's 2 times 24 plus 44 plus 66, which is 134. 2 times 134, which will be 268 centimeters squared. Sorry, it's not centimeters, is it? It's millimeters. Right, so I need to just change that. So we have millimeters squared. Right, so far so good, not too difficult. Right, let's have a look at a different one. Okay, these are the 2 general ones which that you have formulas for, the cube and the cuboid. We have the 6a squared and we have the 2ab plus 2bc plus 2ac. Now we're looking at this prism here. It's like the triangular one. We have 2 sides. It says find the total surface area of the triangular prism. We have 2 sides. We have a front, which is a triangle, and a back. We have a side here on the back side. We have the bottom down here. And then we have this top slanty side. All right, so let's start off with the front and the back. We're looking at this triangle. The area of a triangle is base times height. Okay, we're looking at this. We don't actually have the base, so we need to find the base. Our old friend Pythagoras will help us with that. Okay, so we have this side here. We know this is 10. We know this is 8, and we're looking for this. So x squared plus 8 squared equals 10 squared. So x squared equals 10 squared minus 8 squared, which is 100 minus 64. So x equals the square root of 36. So x equals 6. So we found the base here, which is 6 centimeters. All right, so the area of the two triangular sides. So area, we can say front and back, or we can say two triangles. I'll say two triangles so my person who's reading this can know what I'm doing. I'm going to say is 2 times base times height over 2. I have 2 of those. Okay, I can already see that these two cancel. So it's just the base times the height, which is 6 times 8, which is 48 centimeters squared. Let's find the area of this bottom part. So area of the bottom is going to be 6 times 15, which is 90. The area of the back, that's a rectangle right there at the back. So the area of, I will call that the back rectangle, basically. The back rectangle is 8 times how far back it goes. It goes back 15, so it's 8 times 15, which will be 220, if I'm not mistaken. It's 80 and 40. Sorry, what am I on about? 120. There we go. And then we have this slanty top side. We can see that slanty top side is another rectangle. So the area of the top equals 10 times 15. Goes back 15. So 10 times 15 is 150 centimeters squared. So actually the parts that are not the cross section, so these rectangles that are all the way around, there is another way you could look at that. You could just find the perimeter of this and say 8 plus 10 plus 6 and just multiply your answer by 15. So this, a shortcut way of doing this, could have been 6 plus 8 plus 10, which is the perimeter of that cross section, and then just multiply that by 15. You will get to the same answer as if you had added this 90, 120 and 150. All right, so I think I've got all the sides in. I have 2 front back and 3 all the way around. Altogether, I should have 5 answers here. Well, I have 3 and there are 2 in here, the 2 triangles. So I add them all together. And if I add them all together, I should get 368 centimeters squared. You can put that in your calculator if you want, and you can check that. Or we can even do that in our mind, maybe. 10 and 8 make 18, and another 6 makes 24 times 15. 24 times 15 is 10 24s, which are 240, 5 24s, which are 120, and that comes to 360. Does it? 360. Oh, that's a bit odd, isn't it? Let's just check this. 360 plus the 48. Actually, my answer is 408, if I'm not mistaken. So my answer is this plus that 48, which should come to 408. So this is not 368 here, it's 408. All right, let's continue by looking at this peculiar looking shape. Find the surface area of the block here. Right, we can see here that this shape is not actually a cuboid, even though it looks a little bit like a cuboid. You can see over here we only have 1 centimeter height, whereas over here we have 3 centimeters. So that cannot really be a cuboid. And that is actually the cross section, because as I cut backwards, that will be the shape of cake everybody will get. But we're not finding the volume on this, we're finding the surface area. So let's look at all the different surfaces we have. First of all, let's look at this front and back here. Let's call this front and back rectangles. Okay, so we'll say the area of the front is this 3 times how far back it goes. It goes back 10. So 3 times 10, we'll just say is 30 centimeters squared. And the back here is going to be 1 times 10. So area of the back equals 1 times 10, which is 10 centimeters squared. So we've kind of done the easy part. Now looking at this here shape, okay, we might not be able to easily recognize that what kind of shape that is. Here there's a 90 degrees here, if we can see it. If we turn it upwards, we'll end up with something like this. Okay, it kind of looks more taller and thinner here, because this is not really so much in proportion, because this is 40 centimeters along here. If that's 40, that wouldn't be 3, would it? Be a lot thinner. Okay, so I exaggerated it a bit too much here. Okay, so if I turned it upwards, it would look like this. So this would be my 40 centimeter height. And this 3 here would be this underneath here, 3 centimeters. And you can just try to hold this down a bit. And this up here, this 1 centimeter here would be this 1 centimeter here. Okay, so it's a trapezium. These two are the parallel sides here. This one and this one are the 2 parallel sides. So that's this here and this here. So let's find the area of that trapezium. So the area of that front side, which is the same at the back. So actually maybe I should have not called this front and back. Maybe this should have been the front and back, and these could have been the sides. It doesn't matter. Okay, I'll just say area of trapezium for this. So area of trapezium, and we have 2 of those. We have 1 here and 1 here, so they're opposite each other. 2 times, so I'll call them traps. A plus B over 2 times the vertical heights between them. So A plus B is that 1 plus 3. So 2 times 1 plus 3 over 2 times, what's the vertical distance between them? So the vertical distance between them will be this here length here. So it's times 40. Okay, so we have 2 times 4 divided by 2 is 2. 4 divided by 2 is 2. So 2 times 2 times 40. So 4 times 40 is 160, if I'm not mistaken. So 160 is the 2 trapeziums. Right, so far we have this 30, this 10, and this trapeziums to add together. And now we have to worry about the top and the bottom. Right, let's have a look at the top. The top is 10 by 40. So the area of the top is not so difficult. Can I fit it in down here maybe? Area of top equals 10 times 40, which equals 400 centimeters squared. we may be mistaken into thinking that the bottom is also 400 centimeters squared, but we must be careful because this length here is not in fact the same as this length here because it's not a cuboid. Okay, this length here, which is this length here, is slanted. It's not really perpendicular, is it? So we need to find that length there. If this is 1 centimeter here, then this will be 1 centimeter opposite, which leaves 2 centimeters here. So if I take this right angle triangle out here, just so that I can see it a bit, well, it'll be longer than this, but this will be my 40 height here. This here will be 2 centimeters, and we need to find this slant height because that x is the same as this down here. So that's that x there. So we're using our Pythagoras here. We will say x squared equals 40 squared plus 2 squared. So x squared equals 40 times 40 is 1,600 plus 4 is 1,604. So x will equal the square root of 1604, which is in fact very close to that 40. Okay, if you put that in your calculator, you will get 40.0499. So it's 40.05. So it's almost 40. It's very close because this is so long. And there is very little difference between these two here. So imagine that's going slanting very slowly. It's not very steep. Okay, so let's now find the area of the bottom, knowing that this is a rectangle and this side here is 40.05. So the area of the bottom, equals 40.0499 or 05 multiplied by how far back it goes, which is 10. So we can do that in our mind. That's just 400.5 centimeters squared.